Welcome to The Explainer. Today we're going to talk about something called fuzzy logic. It's this really cool system that, well, it teaches computers to think less like a machine and a little more like us.
I mean, just think about it for a second. How often do you say something is a little warmer or kinda tall? All the time, right? Well, your computer has no idea what you're talking about. For a traditional computer, it's all yes or no, black or white. So, how do we bridge that gap? All right, so to really get this, let's start with how computers usually see the world. And it's pretty simple. It's all black and white. There is no maybe. So what we call traditional or crisp logic, think of it like a light switch. It's either on, that's a 1, or it's off, a 0. That's it. But fuzzy logic, that's more like a dimmer switch. You've got all those levels in between, right? A little bright, kind of dim, mostly bright. It's not about absolute truth, it's about degrees of truth.
Yeah, this all comes from this old idea in logic called the law of the excluded middle. It's a really fancy name for a simple idea. Something is either true or it's not. There's no third option. So, looking at this diagram, an item is either completely in set A or it's completely out of set A. No halfway, no straddling the line. It's one or the other.
Okay, so now for the fun part. Let's introduce the fuzz. This is where we get to break that strict binary rule and see how we can get machines to actually handle the messiness of the real world.
The absolute core of fuzzy logic is this idea of a fuzzy set. So instead of being just in or out, an item can have a degree of membership. It can be, 100% in, 0% in, or literally any value in between.
And this is the breakthrough. This is what lets us represent those vague ideas. So someone who's, say, 6'1" isn't just tall or not tall. In a fuzzy set, they might have a membership of, zero point 0.8 in the set of tall people. They're mostly tall, but they're not 100% tall, right? There are taller people out there.
So you're probably asking, okay, where do these percentages come from? We use something called a membership function. And don't let the name scare you, it's really just a graph. It takes a precise input, like an exact temperature, and it maps it to how fuzzy it is, like how much it belongs to the idea of warm.
And what's really cool is that there's no single way to do this. You have a ton of flexibility. You can define your fuzzy concepts with these sharp, straight-line triangles you see on the left, or you can use smooth, more natural-looking curves like the ones on the right. The shape you pick just depends on what you think best represents the idea you're trying to model.
Okay, enough with the theory, right? Theory is great, but let's see how this whole thing actually works. We're going to walk through a practical example, building a little robot that automatically figures out how much to tip at a restaurant.
So here's our mission. We're going to build a fuzzy system that takes two super subjective, very human inputs, the quality of the service and how good the food was, and get it to spit out a precise, exact tip percentage. And this is how we turn those words into math. Check it out. On the left, we're defining what poor, good, and excellent service actually mean on a scale from 0 to 10. And notice the most important part. They overlap. See how a rating of, say, 3 is a little bit poor, but also a little bit good. It's not one or the other. And we do the exact same thing for the food quality on the right. All right, next up, we need to give our system some rules. And the beauty of this is that they're written just like a person would think. Simple if-then statements that connect our inputs, the service and the food, to what we want to get out, which is the tip.
Okay, so we've got our inputs mapped out and we've got our rules. But how does the system take all this fuzzy information and actually land on one single number for the tip? How does that work?
Well, it's a 4-step process. First, it has to fuzzify the inputs, turn the numbers into fuzzy values. Then, it applies the rules we just wrote. After that, it aggregates, or, combines all the results. And for the final step, it defuzzifies everything back into one single crisp number. Let's walk through it step by step. Okay, step 1, fuzzify. Let's pretend we just finished dinner. The service, was a 2 out of 10. But the food? The food was an 8 out of 10. It was delicious. So the system takes these two specific numbers, 2 and 8, and checks them against those graphs we just made. And boom, here's what it finds. Our service score of 2 is 80% poor, but it's also 20% good. See? It's not just one thing. It's both, just to different degrees. And the same thing happens for our food score of 8. It's mostly delicious, but also a little bit good. All right, on to step 2, applying the rules. The system goes through each rule we wrote and figures out how strongly it applies to our situation. And when it sees a rule with an or, like if service is poor or food is rancid, the fuzzy logic for or is super simple. It just means take whichever value is bigger.
So since our service was 80% poor, that first rule fires up with 80% strength, and that activates the cheap tip output. Now this next bit is called implication, and all it means is we take the shape we defined for a cheap tip, that triangle on the left, and we just slice the top off right at that 80% mark. That's what you're seeing on the right.
Okay, step 3, aggregation. The system does that same slicing thing for every single rule that got activated. So Rule 2 fired at 20% and Rule 3 fired at 60%. Then it just stacks all of those sliced off shapes on top of each other. It combines them into one big, final, kind of weird-looking fuzzy shape.
But that combined shape? It's still fuzzy, right? We need a real number. So that brings us to the final step. Number 4, defuzzification. And a really common way to do this is to find the center of gravity of that final shape. You can literally think of it as finding the perfect balance point, the exact spot where you could balance that shape on the tip of your finger.
And that balance point, that gives us our single, crisp, final number. For our specific dinner, that number is 12.05%. And there you have it, a precise tip calculated from our vague, human feelings about the meal. Pretty cool, huh?
Now, I know what you might be thinking. That seems like a really complicated way to figure out a tip. And yeah, for a tip, it is. But the principle behind it, that's what's powering some seriously sophisticated technology all around us. At the end of the day, fuzzy logic is really just a bridge. It's what allows machines, which think in absolute ones and zeros, to understand and work in our messy, uncertain, kind of vague world. And you find it everywhere. It's in the anti-lock brakes in your car. It's in the camera that's focusing on your face. It's even in your washing machine, helping it figure out just how dirty your clothes are.
And that kind of leaves us with a huge, fascinating question, doesn't it? I mean, we figured out how to translate a concept, like good service, into code. As this tech gets more and more advanced, what other, even more complex parts of the human experience will we be able to teach our machines to finally understand?